Recording in progress.
I want to announce the talk by Pablo Balenzuela from the University of Buenos Aires. That is going to talk about analyzing mass media influence in public opinion using natural language processing and time series analysis. So, Pablo, all yours.
Okay, well, thank you, Celia, and thank you all the organizers for this wonderful meeting. And also for giving me the opportunity to present this work. As you say, this work is an approach we did in our works to deal with the how to measure and how to analyze the influence of mass media in public opinion. This work is from a data-driven approach, was done in collaboration with Victoria Semeshenko, Sebastian Pinto, and Federico Albanese. Okay, so here we are. When we deal with how public, media influence public opinion, we have to think in the agenda setting theory. The agenda setting theory deals with how media influence public opinion and is and was established from the seminal work of McCombs and Shaw in 1972. From this seminal work, there has been a lot of words within the context of this theory. Basically, in this theory, media outlets are represented by the agenda, and we think that the agenda of a mass media as a compilation of topics presented with a certain degree of emphasis in those topics. And the theory, in its basic version, study the correlation between the topics covered by the media and those that are prominent in the public. So a very common approach to this agenda setting theory was in electoral context, because there is a natural way to have a quantifying of the public opinion. For instance, this is a paper of 2009 from Gerber and co-worker, where they deal with the influence of mass media in public opinion in the context of the government election in the state of Virginia in 2005. And they ask themselves, is media exposure to newspaper with different leanings, as the Washington Post and Washington Times, for instance, could influence the behavior of voters. They provide a free subscription to Washington Post and to Washington Times to different group of registered voters, and they analyze with a survey post-election, is media exposure have any consequence in the behavior of the voters. On the other hand, there is another approach based on web data analysis. And in particular, we picked this work, very nice work of Taha Yasseri and Jonathan Bright, in which they study if the analysis of information in Wikipedia pages related with different European elections correlates with some change of behavior of the voter, and the result suggests that the voters seek information only when they are considering changing their vote. So our proposal, and we study in this context, is to understand what features of news media articles can influence public opinion in an electoral context. In this particular case, we focus in 2016 USA presidential election and analyze two kinds of data. Data from electoral polls on voting intention for each candidate. The candidates in that moment were Hillary Clinton and Donald Trump. And also we analyze the content and different metrics of news articles mentioning those candidates. which kind of feature of what kind of metric we analyze of these news media articles? Well, we analyze the amount of mention to each candidate and the sentiment bias towards each candidate, and also the topic of discussion in which this new word were involved. And we study correlation measures and causality measure between these metrics and the time series of the surveys. So let's go to the data. The first part of the data were the surveys, and we take these surveys as a proxy of public opinion. We download from this site here, Real Clear Politics, more than 260 USA national surveys. They came from different pollsters. We can see here in the top panel, vote intention in blue, the vote intention to Hillary Clinton in the 3 months previous to the date of the election. It was from the last Republican convention to the date of the elections. And in red, we can see here the vote intention to Donald Trump. In the bottom panel, we have in green the difference between the vote intention between Hillary Clinton and Donald Trump, and this is the time series we're going to pay more attention. On the other hand, we download from the online site of these news media outlets, the New York Times, Fox News, USA Today, and CNN, all the articles that at least mention one of the 2 candidates, Hillary Clinton and Donald Trump. We choose this media because they are the top 4 media outlets in online searches all across USA territory. So this is, for us, the more representative of the media. And we analyze different aspects of these news articles. The first aspect we analyze is the amount of mention to the candidates. We can see in this plot here, the amount of mention as a function of time from both candidates, in red for Trump and in blue for Clinton, in New York Times, Fox News, CNN, and USA Today. And we calculate sperm correlation with the time series corresponding to the difference in the intention to vote intention. And the first result we can see here is that regardless the candidate, we can see that the correlation are positive for New York Times, CNN, and USA Today, and they are negative for Fox News. It means that when the candidates are more mentioned, the difference between Clinton and Trump decrease. So we wonder why we have this kind of behavior, and our answer was trying to get more insight about what happened with the news. So the first step we did in our analysis was to analyze the sentiment analysis. The sentiment analysis is to understand from an automatized point of view if the context in which the candidates were mentioned were positive or negative. There are several algorithms to analyze the sentiment of a given phrase. We use the Stanford Core NLP, which they build a binary tree from each phrase to determine whether the phrase has positive, negative, or neutral connotation. And they use basically a database with positive, negative, and neutral words. They take into account the sentence structure, and they use also the presence of intensifier, appeaser, or denier. So this is how basically the algorithms work. And the way we use it was the following. For instance, if we have a news article like this, we select from this news article the phrase where Donald Trump or Hillary Clinton were mentioned. We run the algorithms in these sentences, and we collect or we label the phrase with a label is positive, neutral, or negative, according to the result of the algorithm. So we count all the phrases and we collect the fraction of positive mention to Hillary Clinton. This is C+, and did the same from the fraction of negative mention and for Hillary Clinton, and also for Donald Trump, positive and negative amount of fraction. And from these quantities, we calculate a metric that we call the sentiment bias statistic, which is defined like this formula in this part. I don't know, you can see my cursor, and it measures the bias toward the candidate in a given media. For instance, if this metric is positive, it means that the bias is toward Clinton compared with Trump, and vice versa. And when we analyze this metric for all the news we have collected, we can observe here that this metric is positive for all media outlets analyzed, but is more positive for New York Times and USA Today than for CNN and Fox News. For instance, for Fox News, it's almost close to 0. But if we want to know a little bit more about these metrics, we should plot this statistical bias as a function on time. And if we plot this statistical bias as a function on time, we can see here, for instance, that this statistic is always positive for the New York Times, that is the blue line here, but for Fox News and CNN, we can see that there are two particular dates in which they take negative values. So what is happening here? Why it has a negative values? If we want to understand this behavior, we have to move forward to another kind of analysis. And this kind of analysis is related with the content of the news. To analyze the content of the news is, in that way, is to try to infer what is the agenda of the media. Infer the agenda of the media is to understand what are the main topics the media are talking about. And in order to do that, we first take each one of our news articles and represent them like a vector. This vector is a vector in the semantic space. It has as many components as terms we use to describe the document. And in each one of the components, we calculate the time of term T appears in this article. It is multiplied by the specificity term. This is called the TF-IDF approximation. And this tells us which of the terms are more important to describe these articles. If we do that with all the articles in the corpus we analyze, we can represent the whole corpus as a matrix of documents by terms in which each rows correspond to a given document. So the next step was just to identify which is the group of articles that are speaking about the same topics. And in order to do that, we perform an unsupervised clustering. In this particular case, we did non-negative matrix factorization. And when we factorized this matrix, we obtain a group of articles that speak about a given topic. This given topic is represented by a selected group of keywords. So these are the keywords, and this is the group of similar articles related with those keywords. If we focus on, if we go to the corpus we analyze, we can see here that we obtained 5 emergent topics. The first one is the red one that we label as Clinton email controversy. This is a topic in which was related when some news when Hillary Clinton used her private email to public communication. There is also a topic related to economy, which they discuss taxes, a job, etc. There is a topic related to foreign affairs, and also we can see here the presence of a discussion about the inherence of Russia in the electoral process. There is a topic related to immigration. We can remember that Donald Trump put these topics on the scene when he saw that he was going to build a wall between Mexico and the United States. And also there is a topic related to the Clinton Foundation affair. This is there are news related with an issue in which a foundation related with Hillary Clinton received a donation from foreign countries when she was Secretary of State. So this is our reduced space here now. The media are mainly talking about these 5 topics, and if we calculate the amount of news each media outlet gives to each one of these topics, we can have the agenda of this of each media. And this agenda is represented in these radial histograms. This is a radial plot for each one of the media outlets analyzed. And we can see, for instance, here in blue, that the New York Times pay more attention to topic economy, immigration, and foreign affairs. Meanwhile, the Fox News pay more attention to the Clinton Foundation affair, to the Clinton email controversy, and to the immigration. So we can see here in sketch or how is the leaning of each media respect to the candidates. We can plot this, the importance each media outlet gives to each one of the topics. And if we do that, we have plots like this. For instance, this here we have the evolution of the agendas for Fox News, CNN, New York Times, and USA Today. And we can see, for instance, that for the beginning of September, the topic of immigration became a topic of discussion in all media. In particular, it was more emphasized in Fox News. This topic was replaced by the magenta one that speak about foreign affairs. It is several dates of discussion, and we can see here that it's going to be important that for the end of the campaign, the topics related to the Clinton email controversy becomes dominant near the election. If we perform a Spearman correlation between this time series and the difference in the polls between Clinton and Trump, we obtain this table what we can see here, and we observe here that the difference between Clinton and Trump intention to vote correlates negative with a lag between 7 and 10 days, depending on the media, with the topics Clinton email controversy, Clinton Foundation affair, and immigration. So we can see here that these specific topics affect the performance of the candidates in the intention to vote. And also we can see here that the topics economy and foreign affairs are favorable to Hillary Clinton. And we can relate this with the agenda of the media, because the topics that favors Hillary Clinton are the topics that are highlighted or that I more covered by by New York Times, and the topics that are against Hillary Clinton are the most covered by the Fox News broadcast company. So the next step we did is just to to combine both tools and to calculate the sentiment bias statistic, but restricted to each topic. And if we do that, we can see here that the topic that negative correlate with the performance of Hillary Clinton also has a negative sentiment bias statistic, which in some way are supporting the result we have obtained before. So we can move here to the question we have referred before, and if we can remember that we have this statistical bias as a function of the different media outlets, and we have two particular dates in which they take negative values, so they are favored to Donald Trump. And if we want to understand what happened here, we can see now what happened with the media agenda in these particular dates. And we can see the most important here is that just in this date that is close to the election, when the sentiment bias was a negative value, is because the public discussion was dominated by the Clinton email controversy. So if we now see how is the intention to vote, we can see here that an increase in the coverage of topic with a negative bias toward Hillary Clinton is reflected in a loss of the lead in voting intention. So in order to finish this analysis and to know we just and taking into account that not always correlation implies causation, we perform a Granger causality analysis. A Granger causality analysis reveals if the dynamic of a temporal series have a causal relationship with another time series. It consists in determining additional information provided by a second time series improve the forecast of a given one. So the time series we would like to forecast is the one related with the difference between Clinton and Trump, and the question we ask to this model is if the additional information of the time series of the agenda of the media improves the forecast of the difference between Clinton and Trump or not. And we find that for these 4 topics, and with a sign in the coefficient consistent with the correlation, we find that there is a causal relationship between Clinton email controversy, Clinton Foundation affair, and immigration topics with a coefficient, negative coefficient, which is favorable to Donald Trump. And we also found a causal relationship with the topic economy. So these are the main results that I was going to present here. We can move now to the conclusion. We have seen here that the combined approach of topic decomposition and sentiment analysis allow us to see which are the relevant aspects of media influence people voting intentions. We see that the analysis of correlation by topics with the difference in voting intentions allow us to understand the fundamental role played by the topics to understand how the behavior of the voter were in this particular data set. And we also observe that the sentiment analysis discriminated by topics allow us to understand the key role of this given topic, the Clinton email controversy, in this particular election. And also that the Granger test was consistent with the previous results and reinforced the interpretation of a causal relationship between the topics and the voting behavior. I hope you have enjoyed the talk. This is a as I say, this work was done by Federico Albanese, Sebastian Pinto, and in collaboration with Victoria Semeshenko. And if you want to read more about this, you can find it in the Journal of Phase Complexity, which was published last year. So thank you very much.
Thanks to you, Pablo. We go to questions. There are some questions here in the chat that you can read, or Felipe is the first. But also you can raise hands. We have 4 minutes, so who prefer to raise hands here in the Zoom can do it.
Okay, Felipe asked me if the clustering of 5 topics robust. Yes, I mean, we have I don't mention here, but we have swept between 3 and 20 topics, and the most robust decomposition was, in this case, was in 5. But as you have noticed, this is, of course, there is no there is no an optimal way to know a priori if there is an optimal number of topics. We have to just look at the data what we are dealing. We don't know. We have seen the results of the 2020 election, but the curve between the vote intention between Biden and Trump is not so nice to analyze. It's almost flat in the 3 months. So this is not a very nice data to analyze. So we didn't do this particular event, but we have seen the curve, and we didn't go further. No.
There is a hand by Sebastian.
Okay.
Sebastian Gonzalez, you want to ask? Sebastian?
Sebastian, do you want to ask?
You raise that hand?
You hear me?
Or...
Can you hear me?
Yes, yes.
Okay. It seemed to me that the intention of vote to Trump, it was rising before the media coverage of the email issue.
Oh, let me see. Well, here.
Yes, right.
You say.
I mean, it was slowly showing an approximation between the two intention of votes.
Yeah, but you see this final, yes, of course, there is not a single causal reason. Maybe this, you know, that this kind of analysis should have many reasons, but we are not claiming that there is the reason because Trump win the election was for this particular topic, but this was which was very important. But if you see here, let me see here. You can see here that meanwhile the time becomes relevant in this particular date in CNN, USA Today, and Fox News. In Fox News, it appears before here. You know what?
Yeah.
And it's yes. We have seen this behavior in another data sets that one particular media outlets put the topic on the scene, and they become more important for all the media outlets if there is important enough. I mean, it don't happen with all the topics, but it happens with some specific one.
Okay. Thank you, Pablo.
Thank you. There is a last very rapid question by Felipe. I think it was pending.
Hi again.
Hey, Felipe.
We have less than a minute.
I was wondering if it's possible to extend this analysis for other mediums of communication like WhatsApp and Facebook, like tracking groups and how they and what they post, because I feel that this new way of interacting with information changed a little bit how we make our choices in elections.
Well, I don't know how. Yes, thank you for the question. It's very interesting. We have done media analysis and also Twitter analysis. We don't have analyzed Facebooks, and I don't know how to have access to WhatsApp. I also agree with you that it could be interesting to analyze different platforms and to combine this analysis, but sometimes this data is not always available. So what we are doing now is just to combine the data we have analysis with the modeling approach to have a combined, to infer from modeling what is going on with that data we cannot have access. So this is our current approximation to this kind of issues right now.
Oh, sure. Thank you.
So thank you very much. Other questions in the Slack? And now let's share screen to Jorge Revelli from CONICET in Córdoba, Argentina. That's going to talk about entropic analysis of opinion formation model.
Sorry.
Selecciona documentos, Jorge, en vez de herramientas. Ahí te va a aparecer.
Okay, I'm sorry.
No problem.
Right.
Okay.
Can you? I'm sorry.
Can show the documents also.
It's okay?
It's okay, like this is okay.
Okay.
Mm-hmm.
Okay. I wish to thank the organizers for giving me the opportunity to tell you this work, entropic analysis of an opinion formation model presenting a spontaneous third position emergence. It was a work which was carried out in collaboration with my friend and colleague, Marcos Gaudiano. So let's start. What was the motivation? Well, in the first half of the 20th century, politics in Argentina was centered basically around two ideas. These ideas were represented by two political parties, UCR Party and Conservative Party. As a consequence of social kinetics, in the second half part of the 20th century, a third idea or a third political idea emerged, and it was represented by the Justicialist Party. So from the physical point of view, how could we explain this fact? So let me introduce to you the model. Consider a square discrete arrangement composed by lambda square pixels. Each pixel represents an idea associated to a person. There are 3 different ideas or political positions in this configuration map. They are Y, L, and B. Positions Y and L are active ones. These represent active position, and it means they participate in debates. And as a consequence, they can change their opinions. On the other hand, B is a passive position. They do not participate in debate, and consequently, they do not change their opinion at all. Initially, each ideological position has a given number of supporters. Let Ry be the initial fraction of supporters for party Y. Idiosyncrasy was modeled by the SNAG model. SNAG model is a non-biased to a second neighbor model, and also we consider initial conditions. We studied 2 initial conditions, the random one and the structured one. Structured initial condition models essentially affinity among supporters, and also and mainly the how organized are the parties. At long times, the configuration map tends to this figure. And in this context, we have 2 local states. For example, blue panel, white panel, yellow panel, and chessboard-like structure, which we consider this 3rd party, the emerging party. So let me introduce you in how we structure the initial condition. Idea structures are characterized by means of fractal dimension D. In our case, D ranges from 0 to 2. A low dimension means low organization, and high dimension means strong organization. The initial configuration is generated by using the box counting method. Here, I show you a configuration map. This map has a lambda equal 64 side, and in this case, initial fraction y is 0.15 and has a dimension equal to 1.770. Meanwhile, initial fraction of L is 0 equal 15 and dimension L is 1.70. So let me show you the first some results. For example, for random initial conditions, we suppose, and it is important, that our initial fraction of Y supporters are equal to initial fraction of L supporters. It is a good idea because we want to show you that how important is the structure in the evolution of the system. For random initial condition, I show you this figure. This figure represents the probability of winning of a given party as a function of the fraction of neutral or passive population. we identified two regimes, low apathy and high apathy. We pay attention on the high apathy. Here, results in the random initial condition are expected. We see that because we started with the same fraction, initial fraction of supporters to each active supporters, we have the same probability to win the election. Meanwhile, we have zero possibility that a third position wins the election. But what happened when we structure initial conditions is set on the evolution of the system? There is a dramatically difference between the random initial conditions. And now, for example, let's compare the situation where the initial fraction are equal between active parties, and we have in this case Py equal 0.45 and PL equal 0.25. Meanwhile, PG is equal 0.30. Observe that dy is greater than dl. On the other hand, we have in random condition in that regime that Py equal PL equal 0.25 and PG equal 0. On figure, we depict the probability of winning as a function of D for the different parties. And we observe clearly that the emerging party, green, has not a trivial result. So structure matter. Just take a look this graph. In this graph, we depict probability of winning for the emerging party, green, as a function of D, and for parametric size for the initial fraction of the supporters. We observed we observed two different regimes, two monotonous and one non-monotonous. The first one is an increasing one, monotonous increasing one, and the third one is a decreasing one. And let me anticipate you the main result of this work. In these non-monotonous regimes, this one is associated to the maximum unpredictability. But what does it mean? For example, the answer to this question had its origin in a Marcus work, in a previous Marcus work. There, in that work, Marcus obtained two important results. First of all, he studied the general framework of complex systems out of control. There he obtained, the entropy, and as a result, we could relate the initial fraction as a dimension. In that case, we observed that in the high apathy, there is an intrinsic weakness inside the initial structure of Y and L patterns that favors and maximizes the emergence of the third party. Conclusion: initial condition matter, and secondly, hierarchically structured systems have an anomalous entropy production. Well, this is our results published. And finally, I want to invite you to participate in Marco's talk, which will be held on Tuesday, 19th October at 11:30 hours. Thank you very much for your attention.
Okay, thank you very much. There is a question by Sebastian, seems, but the time is over, so I ask you to put in the chat or in the Slack so that Jorge can reply later, maybe, Sebastian. And now the next speaker. Sorry, Jorge, but the time is over.
Okay.
But you can ask, you can answer the questions in the other channels. So now the next speaker is Wesley Cota from the Federal University of Viçosa, Minas Gerais, that is going to talk about infectious diseases with recurrent mobility in particular. So Wesley, you have a total of 15 minutes, okay?
Okay, thank you, Celia. Hello, everyone. As presented by Celia, my name is Wesley Cota. I'm from the Federal University of Viçosa here in Brazil. And I'm going to talk about a paper that we published this year in the New Journal of Physics about metapopulations, introducing the heterogeneous transmission and also the recurrent mobility. So this is a joint work with Davi Soriano Panos, Alexa Renas, Silvio, that is going to present next, and also Jesus Gomes Gardenes from the University of Saragossa in Spain. So I'm going to talk about metapopulations and data-driven theoretical frameworks. So I'll give a very brief introduction for how we get to the metapopulations. So when we think about epidemic models, usually we think in a homogeneous mix, in which we will have different individuals that can have contacts with anyone in a given population. So this is the usual way to handle epidemic models. This is what we saw in many models for COVID-19, for example, and also the famous SIR model, the susceptible, infected, reproducible model. But with that, we can put some contact pattern, for example. So we can assume, for example, that we have 3 different groups, as for example, young, adults, and elderly individuals, and define a matrix that we will say the number of contacts that one group makes with another. So we are increasing the level of realism in the epidemic model. And then we can have a very explicit relationship that is given by complex network, in which we have different individuals represented by the nodes of a network, and the lines represent a contact that one individual makes with another. But these complex networks are very difficult to have real data about complex networks, to build complex networks. So it's difficult to know how many contacts that you make with another person, and use that, for example, to try to predict the COVID-19 curves of infection, for example. But we can still use the complex networks in another way, that is to define the metapopulations. So instead of thinking the nodes as an individual, you can think on the nodes as a subpopulation that holds a set of individuals, and then we can assume a different level of mixing inside each batch and define an epidemic model, how the transmission happens. But the important part here of the complex network is that we have a network of places, for example, municipalities, regions, or states, or counties, and so on. And the lines here will represent the number of individuals that travel daily, for example, from one place to the other, defined by an origin-destination matrix, as exemplified here. So with that, we have a way to put human mobility and also the contact patterns inside each patch to represent the infectious disease dynamics. So this is the usual way. It's nothing new. So many years of literature about that, and of course to try to predict new epidemics. It has been used for influenza, Ebola, dengue, and so on. So it's not new, and we also use it for COVID-19, but I'm not going to talk about COVID-19. But it's just to give an example of the use of these metapopulations that helped us to understand the spatial-temporal spread of a disease. So as physicists, we want to build a theoretical framework to know how to analytically find some relationships between, for example, the epidemic threshold and some real data, for example, the demographic, the mobility, and also the social patterns. So there is a theoretical framework that was presented in Nature Physics by Jesus, Davi, and Alex Arenas, and we use that as a base for the work that I'm going to present. So here they find a relationship of the epidemic threshold with mobility and find the so-called epidemic detriment. That is, we have a probability here that is given by P. That is the probability that an individual decides to move from one patch to the other. And as we increase this mobility by this parameter P, you have an increase of the epidemic threshold. And it's counterintuitive because we would think that as we increase mobility, the people interact more, and then the epidemic is easier to spread, but it's not the case in this theoretical framework. So we try now to introduce the heterogeneous transmission to try to understand what's happening here. So the heterogeneous transmission can change this detriment. So the usual way is to think an homogeneous mixing or compact pattern mixing inside each patch. It's easier to treat analytically, but now we propose a theoretical framework that put a heterogeneous number of contacts inside each patch. So the individuals inside each patch have a different number of contacts. So we have a heterogeneous mixing, not a homogeneous mixing as before. So we can use the same relationship of the metapopulation. We define an origin destination matrix that will give the number of people traveling from one place to the other. But now we assume that each individual has a different number of connectivity. So we assume that one individual makes, I don't know, 5 contacts and the other makes 10. So you don't have anymore the interaction of all the individuals of the subpopulation. So you increase the realism of the model. And these individuals can decide to move with the probability that can be dependent on this connectivity K, and the model is very general for that. And we can write the equations to evaluate, for example, the number of individuals that are visiting or staying in a patch, and then use and build an epidemic model. So here we use the susceptible infected susceptible model, the SIS model, and write Markovian equations. So it's all depend on the connectivity of each individual inside each patch, but also put explicitly the mobility of individuals from one place to the other. So we can write these equations and then finally obtain the epidemic threshold. And as usual, we have a relationship that is the epidemic threshold is given by the inverse of the largest eigenvalue of a matrix. And the matrix here is this one that has all the information of the connectivity, the degree distribution, the probability to move or not, and also the mobility data that is given here, and the demographics. And so we have this relationship, and then we can study a particular case, for example, homogeneous mobility, when you assume that all individuals move with the same probability. It's not depend on K. And we use here a star method to try to understand this epidemic detriment. So in this star network, we assume that the hub has individuals very heterogeneous, or which are a very large number of contacts, and the leaves has a smaller number of contacts in comparison with the hub population. So we can define the probability to a mobility network here. The hub can visit any leaf with the same probability, depending on the number of leaves. But the probability that one leaf decides to move or not to the hub will depend on this parameter there. So in this static case, we have the usual, the normal epidemic threshold for the heterogeneous field theory. Who knows complex networks and epidemic networks, epidemic models in complex networks know this result. So it's fine, because in this static case, we have the heterogeneous field result. But when you put a different mobility, you see again the epidemic depth. So you have an increase of the epidemic threshold as increased mobility, as in the case of the nature of physics. But now, instead of having an homogenization of the number of individuals, we have a homogenization of the degree distributions. So we have this in this particular set of connectivities, but also in the when you assume parallel degree distributions inside each patch, you have this epidemic depth. So we try to understand that. We see the relationship of this epidemic depth with the mobility given by the delta. That is the second value here in the legend. So we see that the maximum value of the epidemic threshold only depends on the level of heterogeneity of connectivity, but the position of the peak here will depend on the mobility itself. So we have more results in the paper about a perturbation theory that can explain this kind of behavior. So the detrimental effect also appears here. But now we can understand that in a microscopic way, in the sense of homogenization of the degree of the connectivity distributions. And it also will depend on the level of heterogeneity. So you have a stronger detrimental effect when you have more heterogeneity in the connectivity. But it will also depend on the demography. If you have less individuals to mix with the hub, for example, you have less individuals that can change the degree distribution of that patch. So that will also depend on this parameter alpha here that gives the relationship of the demographics of the hub and also of the mix. So the model is general. You can use any kind of real-world mobility data, demographic and social data, but it's the social data, the connectivity distributions are more difficult to gather from real situations, but the model is ready to use. The homogenization of these degree distributions causes this detrimental effect, as I said, and this homogenization can be broken when you put a k-dependent mobility. It's not ready here, we are working on that, but the idea here is that we present a very general model that assumes recurrent mobility and heterogeneous transmission, and you can use in any situation to try to model some more realistic situations. So I would like to acknowledge the financial agencies. The scholarship is from campus and also our group in the Federal University of Viçosa and also my co-authors. And that's it. Thanks. And feel free to ask questions.
Thank you very much, Wesley. Can you see there is a question here in the chat? Wesley, can you read it?
Yes.
Or you want, is Marcos? Marcos, can you ask directly?
Oh, yes. I mean, my question is quite simple. Suppose you have a pattern of spread of some disease or infection, or whatever. Can you do the reverse, answer the reverse question? I mean, you have this pattern. Can you predict how people are moving? Or what's the contact between people? For instance, power law, something like that.
Mhm. Let me see if I understood the question. So you have a spread pattern, and then you can try to figure out how people are moving.
Yes.
But I did not understand the power law part. Can you clarify, please?
Marcos?
I
Can you
didn't
clarify?
hear. I didn't
I
hear.
didn't understand the power law part of the question.
No, that's not, power law is just an example. My question is, if you have this dynamic, if you know the dynamics of the infection disease, can you predict how metapopulation, how people are contacting each other? For instance, it's more or less acceptable that people are doing power laws, like many experiments people are having done about the movement of persons in different cities, moving around, etc. So can do you believe that this kind of information about infection disease is spreading could give you information about how people are moving, are contacting themselves?
Yes, I think so. In the works we did with the COVID-19 situation, for example, you can see a clear correlation between the mobility matrix that we have data, for example, from the census, and the spread of the pandemic. So in the works that we presented, we have the analysis of the places that the spatial temporal dynamics of the COVID-19, for example, and you have a clear correlation with the mobility matrix. So I think so you can kind of try to predict the mobility matrix depend on the spread dynamics. I don't know if it answers your question.
Yeah. Okay. You can go on discussing later because we passed the time. Now, Silvio Ferreira is the next speaker who will talk as Silvio Ferreira is also from the University of Viçosa, Brazil, and he's going to talk about echo chambers in Twitter debates on political debates in Brazil. Silvio? You are without microphone, Silvio.
No, you can hear me.
Can hear, but we can hear now, but your
Sure.
screen is away.
Sure. Okay. Can you hear me now?
Yes, Silvio.
Yeah, okay. Now I can go ahead. So I'd like to apologize by this brief confusion to start my talk. And I have to thank the organizer for this invitation and to allow me to return a little bit to some issue that I worked a couple of years ago. It's still very interesting, and I stopped a little bit because of other projects related to COVID-19, but now I can go back and talk a bit for you. I have some delay. I think that I have some problem.
The screen is frozen.
Oh, okay. Now I can talk. I have some problem when I start to share my screen. My microphone go muted. So let's try now. And this is my group. That's the work with me. This is an out of date picture. It's before the pandemic. So Diogo is not with us anymore. We still collaborate, but this works essentially I did in collaboration with Wesley and my collaborators from Spain and Italy. Okay, now it's moving. So a brief summary of my presentation. I will give you a brief introduction with respect to the problem that we're going to tackle, and I will describe the method that we developed a couple of years ago, and I will show some applications to the political debate with respect to the impeachment of the former president of Brazil, Dilma Rousseff. And then you will also show a recent application that some collaborators did with the method that we developed 2 years ago, and some concluding remarks. Details you can find in this paper that we published 2 years ago. So let me talk a little bit about what's happening in Brazil, not only Brazil, but in many other places around the world. We now know that the way that we diffuse the information, the message, our opinions is completely different of the way that we diffused 10, 20 years ago, because the social media is indeed ruling the way how the information spreads. We moved from a communication system which were based on a mediated center, for example, journalists or TV in general, to a more independent process that use the media, the social media to spread news and information. And we know that this kind of information have very strong impacts for the society in general. In particular, here for the problem that I will discuss in Brazil, it has a huge impact. Let me give you some examples that probably everyone in this nice meeting already knows. Now, the elections of 2016 that was already discussed today. There is a lot of information spreading in social media that was important to contribute in a very important way to the outcome of the results of the elections, and not only for elections. For example, the movement in the Brexit was also very influenced by this kind of discussions in social media, and in Brazil too. Most of you must be aware that the last elections, the tone of the elections was very heavy due to information, especially misinformation spread in social media, in particular WhatsApp, that is very hard to control. So the world that we live is being shaped by this kind of information that is propagating different social media. So we would discuss some examples. But before I go to the problem of the impeachment of the President Dilma Rousseff, I'd like to show you a cartoon showing how the polarization in Brazil is something more or less recent with respect to the rest of the elections. Here I'm showing you some the map with the results of the elections since 1994. When you have a single round for the elections, we can see that the country is more or less more or less uniform. You have the states, and the same candidate won in practically all the states, with a few exceptions in 1994 or in 1998. But then we changed the winner, but the pattern is very similar. Also with a single party winning the elections in our states. And then we start to see some polarization, essentially in the north and northeast with the south and center. This polarization is a bit stronger in 2010 and even more in 2014. It was the election when Dilma was elected for the last time. And if you see again, this is the result for the next elections in 2018. We see again a more homogeneous partner with a little polarization in the northeast, but essentially all the country is voted in the same candidate. That was Bolsonaro who won the last election. So we start with homogeneous system. We still got polarized, and then in the last election we are more or less in terms of the rest of the elections, more or less uniform again, with a little of different partner in the northeast of the country. Well, but the situation that I'm going to discuss with you today is the polarization with respect to the impeachment of the former president, Brazilian president Dilma Rousseff, that happened in 2016. This is a very classic picture where you see people protesting against the president and some supporters, and there is a lot of fighting, of discussion, of very hard debates, and the situation was very critical in that time. So we decided what motivated us to do this study, because we were observing this kind of polarization that was very clear in Brazil, not only geographically, but also in the population in general. Everywhere there are some kind of strong polarization. So we decided to analyze the discussion using Twitter, because we have some direct ways to compute the data. So we use some APIs, some public APIs to collect data. It was Wesley who did this big work. We start with we collected 500 around 500 words or hashtags that we select along the time. Essentially with words related, we assume that they were related to the impeachment process. And we collected for a much broader time window, but we would discuss here only the years of the impeachment. That was from March 5 to end of December of 2006. So just one example, how is the amount of message that we collected along the year. So we have some bursts, here some peaks. Usually these bursts are related to some special event. For example, street protests or some votations in the Chamber of Deputies, and so on. And here is the proximity of the impeachment, that we have a lot of activity, and we have this huge amount of messages, and we have to classify the messages. So as was discussed somehow by Balenzuela, we have also to define the sentiments of the message, and according to the words that were used in the message. So we classified in 3 groups. We have those who are against the president, that you can see some hashtags that were used, like Fora Dilma, that means out Dilma, Lula na cadeia, that means Lula in the jail, So there are some ones that were supporting the president. For example, não vai ter golpe. They say that he's not going to have a coup, and so on. And we also defined a neutral sentiment. Neutral sentiment means that it's related to, but do not express any kind of support, or can be used for both of them. For example, for the STF, it's a kind of protest against the Supreme Court that both sides use it to do. We did a manual classification. We hid thousands of messages and take the decision. Myself and Wesley and two friends, Diogo and Gino, who did a big work helping us. And then we could classify the message. And here is the summary. We have more or less a balance between the supporters and those who are against. And this is the balance that we have in our words to define the sentiment of the message. So the idea here is to construct a political communication network. So we classify the sentiments, as I explained before, according to the hashtags. We did a selection considering only the tweets that had summation, not only the content. The idea is to simulate some real social interaction. And if you have a tweet with both sentiments, for example, you say at the same tweet fora Dilma and não vai ter golpe, we excluded these tweets. And finally, to avoid the influence of bots, or to reduce the influence of bots, we considered only the strongly connected component. That means that in that component that you analyze the system, it's possible to send a message from one user to any other user. Okay, so you don't have bots just send a message to the contents. And here is a summary of properties of this strongly connected component. The size of this is the supporters, those who are supporters that they were against Dilma. You can see that the size are more or less the same. It had some properties of these networks. So in the end of the filtering, we stay with only around 20%, less than 20% of the tweets in the total. We did some previous analysis. For example, we analyzed the activity distribution. That's essentially the fraction of people that have sent a given number of tweets in the time window that we investigated. The results are very universal and in agreement with what we can find in the literature. So the activity distribution in these subgroups is similar to general activities in the tweeting in the internet. So here we analyzed other types. For example, the message that you send, the message that you received, and the both messages in the partners is very similar. So it's very general in Twitter debates, this kind of distribution. And now I introduce the method. It's very simple. We define the list of tweets with the given sentiment that we defined previously based on the hashtags that this tweet have. We define the set of a user, that all the tweets that they send with the given sentiment, and we define a polarization. So the sentiment can be -1, 1 or 0, and we do simply an average set to define the polarization of that user. So if you have the polarization is positive, that means that you were defending the president. If the polarization is negative, it just means that you are against the president, is supporting the impeachment. Here is the main result that we find. Here we have some statistics, but in the left side, I show you the strongly connected component that we obtained. In red, I depict the supporters of the president, Dilma, and in blue, those that were against the president, that were supporting the impeachment. You can see that the components are more or less of the same size. and have a lot of interaction among them. So here we have some counting. For example, this is the number of messages according to the polarization of the users. We can see that in those that was against the president, that was supporting the impeachment, we have a broad distribution of activity, and while those who are defending the president, we have a more narrow distribution. And here we see that the activity partners is similar. We have here a peak of activity for those that have a more or less similar, more or less intermediary polarization around 0.7. And here for the supporters of the president, we have a peak in the most polarized people. Here I have an analysis of this network. We analyzed the community. We did an analysis of communities. Here we can see that for the supporters of the president, we have only 2 big communities here, while you have many communities of not negligible size for those who are supporting the impeachment, who are against the president. So there is, even though the 2 communities have more or less the same size, actually they have a different community structure. Those who are supporting impeachment were much more organized than those who are defending the president. Here I show you the effects of the echo chambers, and we have the polarization of the nearest neighbors of a given, the variable polarization of the nearest neighbors of a user in general as a function of the polarization of the user. You can see that the users with positive polarization, you have a lot of neighbors with positive polarization, and the same for those with negative polarization. Just remember, here are those who are supporting the impeachment. Here are those who are against the impeachment. And here's the same analysis, but looking for the content of the message that each user receives. We can see it again, the echo chamber. This is a typical picture of echo chamber. When you see that an individual communicated essentially with somebody of the same opinion, of the same idea. Well, to improve a little bit this classification, we did also an analysis of the spread of content in this network. Now we use the network. This network is a temporal network. You make connection instantaneously when you send a message from one individual to another, and then you can spread some information. You can define some metrics that are important to characterize this problem. You can use, here we use standard epidemic models, but it's not important. You can use any kind of spreading process that the results is more or less the same. And we define 2 quantities, that is the spreadability and the reachability. Essentially, I will talk to you only about the spreadability due to the lack of time. That essentially, if we start with a message, you will see the fractions of individuals that that the information reaches during a given time window. You start with some information, you say how it spreads, and look for the fraction of individuals. So you define the spreadability of the network in this way. And here we show some maybe the most interesting results. This is very robust with respect to variations of the method. When you look for the spreadability as a function of the polarization, you can see that the spreadability is much higher for those who are supporting the impeachment, and while the spreadability of those who are defending the president was much lower. And it's very correlated with a measure that we defined, that is the variability of the users. That essentially, I'm a measure here, how diverse is the is the groups that have a given polarization. So we see that those who are supporting the impeachment have a highly diverse groups with different polarizations. We have those who are really polarized, but those that was moderated. While in the case of the supporters of the president that who are against the impeachment, they were more concentrated in the less heterogeneous population. Here, the mu is essentially the polarization of each group. I will skip this one because it's related with these parameters, and I will show. My time is almost done. A recent application that was done for some collaborators. When they used this method to characterize some debates in different networks, not only Twitter. And this case is not political debates, is some polemic topics like abortion or drug legality and the other stuffs, vax movements. And they observed that social networks like Twitter and Facebook, they always present echo chamber effects, while other networks, for example Reddit, that related to discussions about some issue, we don't have a clear echo chamber effect. So the method was very effective to be applied to other systems too. And concluding, we can say that we analyzed the political political network related to the impeachment of the President Dilma. We characterized the diverseness and activity patterns that are very similar to the others that you see in Twitter in general. And we developed a new approach based on the spreading process, and you could identify the capacity to spread the given information in different communities of different polarizations. And we observed that highly individual systems are more active. Highly polarized individuals are more active and more efficient to spreading the information. And that is an observation. We don't have an explanation that the supporters of former president, they were much less efficient to pass the message than the haters of the president. And I have to acknowledge the support agents that the CAPS that supported the fellowships, and CNPK, PQ, and FAPEMIG who supported the computers and the other things, and also the National Institute of Complex Systems that I'm a member of. They also helped us. I think that's all.
Okay, thank you very much. There are some comments and questions here in the chat. Marcos Gaudiano says it could be interesting to fit a wave equation to the echoes and assess the wave velocity propagation. Have you ever thought about it?
In our case, we don't have an Euclidean space. In this case, we have only a network. So to fit some wave equations, I don't think that I know how to do this in a network when we don't have Euclidean space. But maybe some equivalent measure could be done. But I don't know how to respond to this question right now.
Okay. There is a question by Pablo Balenzuela. Can you read it?
Yes.
In the paper by Cinelli.
Hi, Silvio.
Hi.
Very nice talk. Very nice. I was wondering if, because I have read the paper of Cinelli in PNAS, and I have seen there that in Twitter they calculate the leaning of the users using the leaning of the newspaper they share, and you use a manual classification. I wonder if both methods are equivalent, or there is one of them better than the other. I just would like to see your consideration about that.
Yeah, actually, in that time we have no we have no methodology to do the automatic classification. That Michele Stanini, he's our collaborator. He's now in the big institute that they have a lot of specialists. But now we have a student. Probably he is here in this room. It's called Uga Maya. That is learning machine learning. Is doing this automatically. But I don't have the answer yet. This is obvious follow-up of the work that we have to tackle as soon as possible. We're doing this, but I believe that there is no big difference. I believe, I hope so.
Thank you very much.
Thank you. Just a rapid question. You said you use those messages that make mention to username that to avoid robots.
Yeah.
Do you, since there are a large number of robots in Twitter, this is the way you use to filter?
Actually, we did two things. We use only Twitter with mentions to try to filter the real social interactions, and also we extracted the strongly connected content. For example, if some user just send a message but nobody reply back, we exclude this user. So it's a way to reduce the effects of the robots. We also run some automatic machines, some automatic bots to identify if you are a robot or not. But the result was not very convincing because I was considered a robot in this analysis. If you have a small activities, for example, this automatic bot that identify if you are a robot or not, said, for example, that I was a robot that time. And I think I'm not. So it was a strategy to reduce the impact of the bots. But I think that the positive points for this specific work is that, we have more or less similar size of the components. So if you have robots, we have the influence for similar influence from both sides. So we expect that is I would say it's a problem, but it's not a central problem. Yeah, a central problem. We hope so.
So there is a question by Felipe. There was a question by Sebastian first. Actually, I skipped it. Sebastian, we are on the break already. 1 minute. Sebastian, he said that what was neutral in 2015 may not be.
Yes, it was just a comment. I think, I mean, it has little influence. I mean, putting on considering 2 or 3 more terms. I mean, it was not. I think it was not show anything about neutral, right?
Yeah, actually, I did not show, but we did this analysis. We considered two types of classifications of the neutral ones. One that we include. Okay, we had some. Let me finish this. We have some hashtags that we assume that is not related to the process, so we excluded them. But we included them again in the neutral just to do some robustness analysis, and the results does not change at all. So okay, it's very robust. Yeah, it's very robust.
I can see now the Wesley answer at the same time.
Yeah, you know more or less well.
Okay.
So,
thank you.
There is another question, but just to give the same opportunity to all, let me say that now we have the break. So during this 15 minutes break, everybody can go on answering questions. After the break, we have the posters. So we recommend to listen, watch and listen to the posters before, but who presents the posters will have the opportunity to briefly talk about the work in the session, before starting the discussion. Okay, so if you want to go on with questions in this break, feel free. Felipe wanted to ask.